Here's a problem we have. It says if the height of a rectangular prism, now a rectangular prism is just basically a box, and it says if that prism is decreased by 1/3, what happens to the volume? Well, if we look at a normal prism, we know we have length right here, width right here, height right here, and the volume is simply length times width times height. If we come over to this guy, its length stays the same. Its width stays the same. But its height went down by 1/3. Which, what we have to think is if it goes down by 1/3, what part is left? If you lose 1/3, that means 2/3 of the height is left. Now that's a very important concept. If you think about it like this, if I go in a store and something is 10% off, what percent am I paying for? Well, if it's 10% off, I'm only paying for 90% of the item. So the same thinking needs to go here. If it's decreased by 1/3, what part are you keeping? We're keeping 2/3 of the height. Imagine the height was a 3. Well, 2/3 of 3 would make it just 2. It decreased by 1/3. Only 2 was left. So here we have the volume of this shape because we only messed with one piece. That one piece didn't affect the other. So this is still length times width times 2/3 height. If I bring the 2/3 out, we can see this guy's volume is only 2/3 of the original. Well, if it's only 2/3 of the original, what percent did it go down by? Well, the volume just went down by 1/3 itself. It didn't have any bearing. Normally what they're going to do is they're going to come in here and say, oh, we decreased everybody by 1/3. Excuse me. If they had done that, you would have to write this is 2/3 and this is 2/3, multiplied all that and seen which part you had left. But in this case, again, they only messed with one side, so it wasn't really as difficult of a problem as they tried to make you think it would be. So the final answer here, again, the volume simply went down by 1/3 also.